isomers are nothing but organic compounds which have same structures but different physical and chemical properties. If the plane polarized light, if it is rotated in a clockwise direction, we say it is dextrorotatory. If it is get rotated in anti-clockwise direction, we say it is levorotatory. The isomers, they have the same chemical formula and the same properties, but they are differ in spatial arrangement of what? Ligands. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called coordination compounds. Under that, we have deeply discussed our coordination sphere and we have understood that what is coordination polyhedron, and we also understood that how to calculate the oxidation number of the central metal atom in the coordination complexes, and lastly we have discussed about the nomenclature of coordination compound. In that we have learned that if they have given the name, how to write the formula, if formula which has been given, how to calculate their oxidation state along with their name also we have learned. Is it right? Today we will move on to the next topic of this unit by understanding what is an isomerism and their types. Okay. So first I'll go with the isomers. So already in our lower classes we have understood that isomers are nothing but organic compounds which have same structures but different physical and chemical properties. Is it right? So isomers are the compounds which are having same structures but differs in physical and chemical properties. So again these isomers are of two types. One is stereoisomerism and another one is structural isomerism. If I say it is stereoisomerism, remember these are the isomers which are differ in spatial arrangement of atoms. Okay, such isomers are known as stereoisomerism. When it comes to the stereoisomerism, again there are of two types. One is geometrical isomerism and one is optical isomerism. And we have one more class of isomers are known as structural isomerism. In this kinds of isomerism, you know, the structure of the isomers are differs in their nature. Hence it is known as structural isomerism. Again there are of four types. They are linkage isomerism, coordination isomerism and ionization isomerism and solvate isomerism. We will discuss one by one because from the isomerism part, you know, any one of the questions will be asked. Okay, we will understand what is isomerism once again and their types we will understand now. Okay, so isomers are the two or more compounds that have same chemical formula but differs in their arrangement of the atoms. Because of the different arrangement of the atoms, you know, they exhibit the different physical and their chemical properties. So what is an isomerism? Always remember, if I say it is an isomerism, it is nothing but a two or more compounds, or if you consider any two compounds, if you compare them, you know, it has same chemical formula. It has what? Same chemical formula, but there is a difference in the arrangement of the atom. Such ones are known as isomers and a phenomena which is known as what? Isomerism. Okay. So again we have understood that isomers are of two types, stereoisomerism and structural isomerism. So what is the stereoisomerism? These are the isomers. They are differ in spatial arrangement of atoms and they have a two type. Again it is geometrical isomerism and optical isomers. Okay. We will see what is a structural isomerism. Structural isomers, they have different chemical bonds and they are further classified into four types. They are linkage isomers, coordination isomers and ionization isomers and solvate isomerism. So if I say the stereoisomerism, always remember there will be a different spatial arrangement of atom. If I say it is Structural isomerism, already I said that due to the differ in their structure, that is because of the different spatial arrangement of the atoms which are involved in formation of bond. Okay, that is known as structural isomerism. Again, there are 4 types. We will see what is that in detail in the next slide. Okay, first I'll go with the stereoisomerism. Okay, in that first class is geometrical isomerism. It is a phenomena in which two complex compounds have same molecular formula and the same chemical bonds but differs in geometrical arrangement of ligand. The two forms are known as cis and trans form and generally which is found in coordination number 4 and 6. So what does the geometrical isomerism says that? Here also the isomers, they have the same chemical formula and the same properties. But they are different spatial arrangement of what? Ligands. So if the ligands are present in one side, we say it is cis isomers. If it is present in opposite sides, we say it is trans isomers. Okay, and usually this geometrical isomerism will be absorbed in a coordination complex or coordination compound which are having the coordination number around 4 and 6. We'll see by taking the square planar complexes as an example. In this, the complexes with a formula known as mx2l2 where x2 and l2 which represents unit ligand which exhibits this geometrical isomerism with the cis isomers and trans isomers. Here I have an example of platinum, that is dichloride of platinum. You can see that in this the platinum which is having +4 oxidation state, as I have said that the compound should consist of central metal atom where that central metal atom should have a coordination number around 4 and 6. So central metal atom which is having the +4 oxidation state, is it right? You can see that this 2-chlorido and 2 amino groups are present in the same side. Okay, hence such isomers are known as what? Cis isomers. You can see that 2 chlorine groups are very closer to each other. Similarly, 2 nitro groups are amino groups are very closer to each other. Such arrangements are known as what? Cis isomers arrangement. Next, we have one more type where you can see that 2 chlorine groups are present in an opposite end. Similarly, the amino groups are also present in opposite end. So this indicates that they are not very closer to each other. They are present at opposite end. Hence, it forms what? Trans isomers. So this will be absorbed in a coordination compound whose coordination number will be vary between 4 to 6. So, hope you all understood with the geometrical isomerism. Always remember, in this kinds of isomers, only the ligating ligands, they are arranged in cis form as well as in a trans form. Their geometrical shape will be get changed because of the arrangement of this ligands in a cis form as well as in a trans form. Hence, it is known as what? Geometrical isomerism. Next, we'll take out one more example to understand this geometrical isomerism by taking octahedral complexes. In the octahedral complexes, usually we know that it has an oxidation number of 6 and the formula of this compound will be goes like this mx2l4 and it exhibits that x2 and l2 are nothing but a ligands. Okay, the compound will be 4 tetramino 2 dichloride of cobalt 6. Okay, in this you can see that this is my central metal atom which is surrounded by 6 ligands. In that 4 ligands you can say that they are present in the lower side and you can say that another 2 kinds of ligand they are very closer to each other. Is it right? Hence it is a cis form. Okay. Similarly, you can see that we have one more type where you can see that all the 6 ligating ligands are present in the octahedral form, but the 2 ligands are known as chlorine. They are present at the opposite end and forms what? Trans form. So you can see that in a square planar structure as well as in octahedral structure, even though the central metal atom is having the +4 and +6 oxidation state, the arrangement, the spatial arrangement of these ligands are different. It may exist in a cis form, either it can exist in a trans form and give rise to the geometrical isomerism in an octahedral complex formation. Okay. Next we have octahedral complexes of the formula MH2 L minus L2. It exhibits the geometrical isomerism where L minus L is a bidentate ligand. Example, NH2, CH2, CH2, NH2, En. What does En stands here? En, which is nothing but a ethane 1,2 diamine. Okay. So, geometrical isomerism of ethane 1,2 diamine dichloride of cobalt. So, cobalt is my central metal atom. You can see that it consists of 2 chlorine group and 2 En groups. These chlorine groups are present very closer to one another and give rise to the cis form. Similarly, you can see that these 2 chlorine groups, they can present in a different spatial arrangement. It will be get opposite to each other and give rise to the trans form. Okay. This is how we can easily remember the geometrical isomerism, where the ligands, their arrangement will be quite different. It will be exists very closer to each other and sometime it will be arranged in opposite directions and they are far away from each other, giving rise to the trans isomers and cis isomers. Okay. Next we have the octahedral complexes of Me3B3 exhibits another type of geometrical isomerism, one which is known as facial isomers, which is named as FAC, as well as meridional isomers, and it will be having MER, short form. Okay. You can say that the central metal atom is a cobalt, which is surrounded by 2 different kinds of ligand. One is amino and one is NO2. Is it right? You can see that all NO2 groups, they are present very closer to each other. Is it right? And you can see that other 3 remaining amino groups, they are very closer to each other. Is it right? This indicates that they are forming what? Facial isomers. So, they are very closer in their faces. But if you see that meridional isomers formation, you can see that the NO2 groups are arranged at a different direction. Similarly, the NO3 groups are also differs and forms a meridional isomers. Okay. So, the facial isomers are 3 donor atoms of the same ligand. They occupies in an adjacent side as I have explained. And in the meridional isomers, the position of the donor atoms are surrounded by meridional or in the octahedral form. Okay. Why I have written only the slash with the 3 plus instead of writing this full what you call coordination sphere, we can write it in a short form and you can write it as like this and show the charges. Okay. Next we have one more type, that is optical isomerism. The phenomena in which 2 complex compounds have same molecular formula and the same chemical bonds but cannot be superimposed on one another. They differ in rotation of plane polarized light. These isomers are known as enantiomers and these 2 forms are also known as dextrorotatory and levorotatory. So, if the 2 organic compounds having same chemical bonds and the same chemical formula, but they differ in what? The rotation of plane polarized light. If the plane polarized light, if it is rotated in a clockwise direction, we say it is dextrorotatory. If it is get rotated in anti-clockwise direction, we say it is levorotatory. They cannot be superimposable. Okay. You can see that the cobalt is a central metal atom surrounded by 3 En. En stands for again ethane 1,2 diamine. Okay. So, when these complexes are surrounded by cobalt, you can see that all the 3 Ens are present in one side. If you place a mirror to this dextrorotatory, you will get a mirror images of another one. Okay. So where you can see that En will becomes this side. Similarly, the En will be goes on the opposite end and En will becomes on the same side. This indicates that they cannot, when you place the or when you rotate the plane polarized light in a clockwise direction, we get a dextrorotatory, and if you rotate the plane polarized light in the opposite, that is in anti-clockwise direction, we will get a levorotatory. And optical isomerism, which is common in octahedral complexes involving bidentate ligand, and DN and L of the one which is stand for only the cis isomers which are showed by optical activity. So from this we can easily understand, even though the organic compounds which are having same chemical formula and the same chemical bond, but the rotation of the plane polarized, if it is in clockwise, it gives rise to the different isomers. If it is in rotated at anti-clockwise direction, it gives rise to the different isomers. Like this, the optical isomers which is also obtained due to the spatial arrangement of the atom. Next we have structural isomerism. Structural isomers are the same chemical formula but they have a different chemical bonds. Already we have understood that structural isomerism are the compounds which are having the same chemical formula but they are differ in chemical bonds. So the first one I will go with the linkage isomerism. The linkage isomerism is a type of isomerism in which two complex compounds are differ in donor atoms of the ligand. They are differ in ligating atoms and they are showed by a complex which are containing ambidentate ligand. It is very important. So here you can see that this is my central metal atom and it is surrounded by two type of ambidentate ligand. One is pentamino and one is nitrido. Is it right? So these two ligands are differs. You can see that this ligands are also differs only when nitrogen is acting as a ligating ligand. If it is ligating by oxygen, their isomerism will be, their characters will be get differs. Hence it is known as linkage isomerism. You can see that one is an ambidentate ligand, in that nitrogen will be acting like a ligating ligand. In this ligand you can see that oxygen itself will be act as a ligating ligand, even though it is having same molecular formula but their linkage ligands are differs because due to the ambidentate ligand. So we have one more example. You can see that in this example, you know, the thiocyanate group is a ligating ligand, but here you can see that nitrogen is a ligating ligand and it is isothiocyanate. Okay, so the ligating ligands will be itself will be differs in their nature. Hence it is known as what? Linkage isomers. What is coordination isomerism? The coordination isomerism is a type of isomerism due to the inter-exchange of the ligand between the cationic and anionic entities of the different metal ions. They are present in complexes. Here you can see that this is a cationic complexes and this is my anionic complexes. Again this is my cationic complexes and anionic complexes. So this kind of isomerism which is always formed due to the interactions between cationic entity as well as with the anionic entity and results in a formation of what? Coordination isomers. So hope you are understood with the example. We will see with the last two examples, last two types. One is ionization isomerism. Ionization isomerism is a type of isomerism in which two complex compounds are produces different ions in the solution form. For example, you can see that pentamino chlorido cobalt and oxidation state of the cobalt you need to calculate sulfate. If you dissolve this, you know, the sulfate will be goes to the water. Similarly, the same compound but it consists of chloride at outside. Okay. So this is a counter ion. So the pentamino sulfate cobalt chlorido. Is it right? So if you dissolve this, you can see that chloride group will be goes into the solution. Similarly, in this example, sulfate will be goes into the solution. This indicates that during the ionization, even though the compounds which are having the same chemical formula, the ions which goes into the solutions are differs. Hence, it is known as what? Ionization isomerism. Next, we have solvate isomerism. Solvate isomerism is a type of isomerism in which complex compounds are differ in number of water molecule acting like a ligand and water of hydration. Hence, this is also known as hydrate isomerism when water is involved as a solvent. Here you can see that it is hexa aqua trichloridochromium. Is it right? And when it is dissolved in a water, you know, this complex which gives to the violet. Suppose if the all 6 water ligands are replaced with one chlorine ligands, you know, it gives to the grey-green color. This indicates that even though the central metal atoms are surrounded by 6 aqua ligands, that is oxygen water molecule, if any one of the ligands are replaced with a chloride, their color will be get changed. This indicates that they are hydrated isomerism. So when it is dissolved, you know, in water, they give us the different colors, hence it is known as solvate isomerism. Okay. So in the next class, we are going to understand the Werner theory of coordination complex. By this, I like to say that especially in the isomerism topic, you know, any one of the topics, any one of the questions will be asked for your final board. It may be from the structural isomerism, either it may be from stereoisomerism. Have a look on it and try to work out with the examples. Always when you are writing the example with the structural as well as with the stereo, always take 2 isomers, okay, always take 2 sets of complex and compare the examples. If you write only one example, they won't give a mark. Always write the 2 complexes and compare their natures. Okay, hope you understood this session. We'll meet you with the next session. Till then, take care, be safe. Thank you.